Good afternoon, everyone, and welcome to our webinar, Revolutionizing Plastics Manufacturing with Industrial Internet of Things Technology. Today, we're going to be exploring this topic. My name is Ron Klotz. I'm an Executive VP at Godlin and one of the original architects of the solution called Prophecy. And I'm also joined by Sean Emerson, one of our senior consultants within Industrial Internet of Things. Today, myself and Sean are going to take you through this exciting topic, and we're excited to show you some practical applications for our manufacturers to help deal with some real world problems. So let's jump right in and get going. Some of the challenges when talking to our plastics manufacturing customers, we're seeing a lot of things that are happening within the industry right now. There's a lot of things going on. First of all, these customers are facing unprecedented challenges just from the recovery that's been created. This is a really good problem to have, and also at the same time, it's a real challenging problem. So as customers are trying to return to normal, these demands are creating all types of disruptions for them and also opportunities. Within these areas, we also see customers that are coming to our manufacturers are really just having very new and challenging expectations. Plastics manufacturers are faced with the reality that these expectations around products have changed, accelerated. They're looking for rapid delivery. They're looking for product variations, changing stocking levels, and all types of expectations that are getting placed upon plastics manufacturers today. We're seeing unprecedented supply chain issues. This one's the one that I think is keeping a lot of executives up at night. These challenges are kind of like some new ones that we've never really kind of had to tackle before. We're seeing shortages. We're seeing all types of disruptions within the supply chains around raw materials. Unprecedented delays puts all types of pressures on planning. The petrochemical industry on a whole is just on a really wild ride, and obviously none of us have a crystal ball, and we're not sure exactly where this is going to end. But within these, challenges also can create some opportunities. Another big challenge is that when we look at the shop floors of our manufacturers, the industry as a whole has lost a lot of workers. That is creating challenges. Unfortunately, what I'm seeing, this trend is not something that's going to ease up anytime soon. So there brings a renewed interest as how do we maintain those skilled workers that we have, and then look to cross-train and help the workers as we continue to try to move the business forward. And last but not least, all this is coming with what I would call margin and competitive pressure. It's coming like from every angle. These are things in some companies that we enjoyed an area that maybe we didn't have to look at productivity and scrap and efficiency, maybe as hard as maybe we have to today, right? And this is also creating the pressure for companies to where innovation and automation to protect the future is probably never more important than it is today. So welcome everyone. That brings us to our discussion of really how do we look to revolutionize manufacturing, plastics manufacturing for the future? Today, we're going to talk about what I would call practical automation meets production reality. How do we do that with understanding that machines are going to break, scrap is going to happen, people are going to make mistakes. This is our opportunity to kind of reimagine the shop floor of the future. This journey really starts with the whole concept around smart factory. How do we take and look to automate and tie in to those critical key assets that our companies, the companies here on the phone, have placed a lot of investment into? All the various types of injection mold and compression mold and blow film mold machines, all this automation, right? Well, I think the good news is the automation is there, but a lot of times companies haven't connected all the dots so that they can complete the journey. So today we're going to talk about an application called Prophecy, which is going to enable this smart factory. So within this arena, we're really going to talk about some three primary areas. One is obviously all the investment into the capital equipment and the machines. how those machines can get connected to the factory of the future, and the role that they're going to play in that connection to allow us to revolutionize the shop floor. There's also going to be need for how we reimagine the shop floor and the shop floor workers. So that factory and that plant floor, the engagement of how your key employees are going to engage within their processes of the future. We're going to talk about new things, which today on most of your what I would call the injection mold or compression mold machines, there's probably human machine interfaces there that operators to some degree do interact with today. We're going to talk about the evolution of that, the role that kind of a smart factory can play with key machine information also combined with other information that may come from your manufacturing applications. And then we're going to talk about the enterprise, how we can look at visualization, how can we know where we have an issue, where do we focus, where do we manage by exception, those types of things. That's all part of the journey and the discussion we're going to have today. So as we start down this journey, there's really two paths that companies can take to get a quick time to value. The very simple one, a lot of times with the machines that you purchase, you'll find that they have some basic machine monitoring. This is software that's usually limited to the platform that the machine builder gives you, but it's some type of software that allow you to basically do some monitoring. That monitoring will let you know maybe when a key fault has occurred or a key breakpoint has gone off on the machine, and we know it's time to do some type of preventative maintenance or repair. The challenge with most of those platforms is they really don't extend across all the other machines that are in the factory. Well, that's where our approach is different. We want to talk to all the machines, not just some of the machines. So look at machine monitoring as a way that we can get the machines connected up to the manufacturing network. And by doing so, now we can start to look at machine monitoring in a very simple and pragmatic way. How do we look at those key failure points on a key given machine and then know, one, obviously when something happens, but then also set up capabilities so that we maybe can get some predictive nature to know that something's about to happen so that we can prevent the downtime and maybe prevent the scrap. And then the second phase we're going to talk about is more about factory automation. And this is where, based on what I would call the setup of the machine monitoring, we now start to build upon that, and we start to look and maybe get connected to your ERP system so that we can start to really look to kind of revolutionize the manufacturing process. This is where we would gauge production information, maybe quality information, and other types of key data points so that we can really simplify operator engagement surrounding the production. Sometimes it can be very limited to no operator engagement because you may have machines that are set up to run for days or weeks at a time, and we really need unattended monitoring and production reporting in those scenarios. The good news is it doesn't, with the application, you really get to dial it into your environment and the type of manufacturing you're doing. Okay, so those are the two kind of approaches and use cases we see that really our customers are looking to deploy. So on this journey, kind of what's important and how do we do this? Well, first and foremost, all the various injection mold machines, compression mold, blow mold machines, the machine builders put a lot of data on there that we can get access to. Now, if the newer machines have a PLC, that's great. But I guess the good news is there's a lot of data there. The bad news is that was there for the machine builder's purposes. So we want to be able to get to the data, but the key is not only getting to that data on the machine, is then how we start to put that in context and transform that data so we can take action on it. So we compartmentalize that data within the Prophecy application, things that are related to performance. Some things will be there for maintenance and quality, efficiency, for example. Everybody would love to know uptime and downtime related to their key assets, getting to real true efficiency. A lot of times we start out with the best of intentions. We have an 8-hour shift, and the next thing you know, we're down to like an hour and a half of true productivity. Well, how do we get there, right? That's the adage of we want to, try to get in and do the root cause analysis, but a lot of times the data is not there to really support that effort. That's the path that we're going to change. So with this transformation, getting this data, we're kind of really converting that into action and placing it in context then with the manufacturing that we're doing, the parts that we're running, the type of quality that we expect, so that we can simplify the operator engagement. So as I mentioned, the first step is around the machine monitoring. This is where we need to set up the basics. The basics is the application comes out of the box with a lot of capabilities ready to go. So as we have temperature, pressure, voltage, other types of things that are going to be the key failure points on the machine, we can set those up, and then we start to monitor those so that we have high and low limits of kind of alerting, if you will, and that can be sent off to an email. It can be sent off to a text message. It can be displayed on one of the displays throughout the factory. We also have the ability to monitor something called rate of change. So this is where if I have a pressure that would go up or go down exponentially based on a certain rate, then that may indicate a future failure. So think of this as almost like a basic machine learning or AI type of capability that's in the product. There again, we don't want to have to sit and watch the data to look for the issue. We set it up, allow the automatic alerting, the managed by exception in the application to do for that automatically. Now, the good news is with those connections, we can now monitor visually throughout the factory. So we use the term Andon board. A lot of companies have this as like a spreadsheet or maybe a whiteboard called a grease board out on the factory floor, to where we have something that's just visualizing how the machines are running and how we're performing. It may show upper and lower limits. It may show that maybe we've triggered an upcoming preventative maintenance cycle that would need to be performed. A lot of companies with preventative maintenance, it's just really the best guess. I think I should do maybe every 6 months, and I change filters and I change certain things within the machine just as a normal protocol. Well, we can enhance that because now we can bring number of cycles, hours run, etc., into the matrix so that we can be a little smarter about the calculations of when and how we would perform a preventative maintenance action. Now this leads us to our second phase, which is factory automation. This is the phase that we take and combine the key machine data along with the key manufacturing specification data. So a lot of times this data is housed in your ERP system. We've got a lot of experience with a couple of different ERPs, and within this, there's usually a manufacturing specification, maybe a work order, maybe a bill of manufacture, but it's within there that the specifications need to be combined with key machine data so that an operator can effectively produce a high quality product according to specifications and time constraints potentially. So as I mentioned, you could have a lot of operator interaction depending on the type of industry that you're in, or you might have environments to where we just set up a certain injection mold machine and it's going to run unattended for maybe 2, 3, 4 days at a time. And we just want to monitor that sort of from afar. And then behind the scenes, we record information related to that production coming off the machine with very little to no operator interaction. So the good news is there's not one size that fits all here. We'll talk about how we design these HMIs kind of built to your environment so that we can really dial it into your production process. The key is by doing that, we also now can impact the ecosystem in which we know that production and the operators have to live in. A lot of times they get their production either from a visual dispatch list that may be deployed from production control, or it may come from the system itself, which might be an online dispatch list. Well, we can display that information on the HMI so it keeps the operator from having to ever leave the station. In there, they may be able to select production or the part that they're going to be producing, get all the specifications, and then based on machine and production activity, we can now perform in an automated fashion all the transactions necessary for that ERP platform behind the scenes. We'll see an example. We'll talk about that. But this gives companies an opportunity to where before everything was really controlled by the operator. They either wrote it down or they went and keyed it in another system. We can take away all those added steps and all that, what I would call non-value adding activity, which can make you very lean. And we can do that by a simplified HMI that is multifunctional. In the same light, we want to see that our groups of machines, maybe the injection mold machines or the compression molds or the blow film molds, the group, how are they performing? Maybe we want to see this on a TV, so you can display any and all of the visualizations that we create in Prophecy. You can display those on just a normal TV. It's a directed URL. You put something in like a little Raspberry Pi, and now you have a live feed showing exactly the shop performance of any key area of the shop. So teams will know how they're doing. This can kind of be important so that you can start to drive, people to where we have an issue. I may have a down situation, etc. And it's a very interactive way that now you can monitor team performance so that everyone on the factory floor knows what's going on and where we may need to focus effort or attention. So with that, let's talk about the little example that we want to do today. And I'll be helped out by my colleague Sean here. But let me kind of set the stage of the little example that we're going to do. So in our example, we have a molded part that's actually a cell phone skin. It's probably not important, but it's just an injection molded part. And that part in our ERP system basically has 3 parts. So think of it as a 3-cavity mold that's compressing out this component. We're going to be using a certain type of resin. Within there, we've required that we're going to have some setup. We know we have a production quantity target that we want to hit. We have some quality that we need to adhere to. As we understand, along the life, you need to know, hey, if we're scrapping out or doing regrind, etc., how do we deal with that? And then invariably, life's not perfect and sometimes things break. So this is our little example, and our little job order that we have in our system is we're going to pump out, or we're going to do 1 injection mold cycle, and from that we're going to get 3 parts from the mold. So with that, I will take it and turn it over to Sean so we can take a look and see an example. Sean, take it away.
Okay. Let me get going here, sharing my screen. Can everybody see my screen okay?
Yes, sir.
Okay. So we start out, like Ron said, we start out in SyteLine CSI with the job to generate these cell phone skins. Now, normally you would print off some sort of a traveler to send over to the work center to tell the guy what he has to generate, but we're not going to do that. We're going to be able to use our HMI to go in, right in and find out what jobs have been assigned to the work center that we're working with here. And this job operation is going to be assigned to work center MLD 10. And we've got some basic information here that SyteLine will use later with our data to determine, how well we're doing. So we come over here to the actual HMI that we're using here. Real quick tour around this thing. We've got machine settings here that come directly from the machines. We're actually going out and asking, what setting are you using for your barrel temperature, your mold temperature, clamp force, etc. And we're just reporting that here. We don't control your machine from this HMI. That's just a liability issue for us. But with our toolkit, if you wanted to, you could probably get in and provide some controls. We have some basic monitors here of temperature, just kind of an Andon stack showing whether it's good or not. Up here, we've got our interface for our CSI data that's coming in. Like I say, this would normally come in as a traveler. And I'll show you the rest of it in a little bit. Right now, the machine is offline. So let's go online here and connect the machine up. You'll notice the temperature right now is pretty low. As soon as we go online, it starts warming up, and we can see our mold temp and our barrel temperatures heating up. As they reach temperature, you see that the Andon indicators are going green, saying that we're ready to go with them. Our job is taken from CSI, and we've got a drop down here. Right now, there's only one job, one active job that's assigned to this work center. But if there were more than one, the user would be able to pick which job you wanted to run here. We select the job, and then that loads up all the information here. Since there's only one, it loaded up as soon as we started the diagram. Now, in CSI, they released 50 items of this, and we show from CSI that one of them has already been delivered. So normally our batch would be, we're going to generate 49 of those, but we can override that. And let's just do a sub run of 5 here. And in a second, that'll update here. So we're only going to run 5. We start setup, and you'll notice over here that we've got a kind of a OEE performance monitor. How long have we been doing certain things for this cycle, and how long has it been going for total? And we can also send this information to a database so that we can track it in over days or weeks and kind of get good trend following analysis with this. You go through whatever steps you need to set up the machine to get it ready to run. When you're ready to run, we'll either ask the machine, if it's running, or we can go ahead like I'm doing here and just hitting a start run. So we start with clamping the mold together, and you don't want to slam these things together. You want to give it some time and build up pressure so we don't break the mold. It takes about 9 or 10 seconds for that clamp to come up to full pressure. Then we start injecting, and you can see that we've got an injection pressure here. We're showing green on our injection pressure and back pressure. And after the injection is done, it holds for a few seconds, cools off, and then returns to home and begins the next cycle. And as you can see, we're tracking over here how many pieces we've produced that are good. We've got the total produced here, the batch progress, and everything like that. We're injecting a second one here. We're showing the percentage of the job that we run here. Now, part of any job is quality control, and this one's running slow enough that the guy can probably look as these things are coming off and identify problems as they're happening. So suppose he sees that this is coming off with some bubbling in one of the parts that have come off. So we hit QC hold saying, hey, stop, we've got a problem. And this will go through the current injection cycle and stop when we've finished that. And we can pick from a variety of different failure modes that may happen here. And we can say how many of these that we see have this problem. And when we hit update, this goes out and conducts a transaction with CSI and actually records that that QC results. So if we go over here and we look at the test results and update that, and we see here that we've got a quantity failed of 2 of bubbling, and that's just what we put in there. And we see here on this pie chart, we've got 1 good part that we've created and 2 bad parts that have been scrapped. We show our total scrapped as 2. And it backed off the number of good parts that it created because, we want to produce 5 good parts at the end of the day. So we've already scrapped 2. So out of the 4 that we've built, we've scrapped 2. And so it just keeps pressing on here. And you can see that while we were in that QC hold, we had that held for 29 seconds. So that's basically what happens here. But, not everything goes well all the time. Sometimes bad things happen. And suppose you have a catastrophic failure, your clamp hydraulic pressure failed. And boom, we go into a failure mode here. We stop the production processing here. We're showing on our Andon board that we've got failures in clamp force and of course back pressure as a result of that. And down here we have a message. We've got a clamp hydraulic failure. Do we want to support or submit a maintenance ticket? And this would then create a maintenance ticket in CSI. So if we went ahead and submitted that, it'll conduct that transaction in CSI, and then should return back to the operations that we're doing here. And if we go over here, let's take a look. Refreshing. So right here at June 14th at 2:28, we had a clamp hydraulic failure on this unit right here. So that was automatically sent back up to CSI from our operation. Okay.
And for those folks on today that may not be familiar with Cloud Suite Industrial or CSI SyteLine, just understand that we do integrate to other ERP applications. So we're just doing this as an example that it is connected to ERP, and that's what Sean is talking about.
Okay. So once we recover from the hydraulic failure there, it should go on and continue on. But, you know, maybe this requires, oh, there we go. It's coming up now. And it resumes the job that it was running. Once we complete the run, then we can hit end run, and it'll perform a job transaction back to CSI. So we'll just shut it down at the end of this next cycle here. Notice that our OE data is updating for quality and availability, performance, and then overall is just an aggregate of those data. So let's go ahead and hit end run and shut down the job. Okay, this little green flag up here says that we conducted a CSI transaction there. So we go into unposted job transactions and we refresh the data. And there we have our job 97. But the unposted job transaction is set up to actually, without you having to go back to CSI, go back and make the entries automatically. So no human interaction is necessary. So unless there's any questions, I'm going to turn this back over to Ron.
Excellent. Thank you, Sean. And the key takeaway there is that we wanted a simplified and unified screen so that operators that maybe not running certain applications all the time, we can mitigate a lot of the necessarily cross-training because the intelligence can be within the HMI itself, try to automate the transactions in the background, and then give an operator an easy way to deal with various disruptions that are going to occur. The good news is based on your production and your type of process, this is where you can utilize the toolkit in Prophecy that allows us to have the HMI's designs based on whether you're doing injection molding, compression molding, blow film molding, etc. And then by having that uniqueness, you can really dial this in so that your operators and your teams have a simplified engagement. And that's kind of the key. We made this so that it's really drag and drop. We made it so that you can utilize very state-of-the-art techniques like REST APIs to be able to communicate to your application. And that application can reside, of course, on premise and in the cloud. It really doesn't matter. So this is where you can kind of just utilize the IoT platform and then embed this into your current ecosystem and your current ERP and your current solutions. If you have analytical tools, for example, you might want us to be able to publish data to that analytical tool. If you have visualizations like within your ERP, you want to have dashboards. You can call any of the Prophecy IoT widgets and place those visually within your environment. And like I mentioned, if you do have an analytics application or you have a data lake, someplace that you want to publish out data that's then going to be used for root cause analysis, we have an automation engine in Prophecy to allow you to aggregate, accumulate, and then push that data out to these other applications. And we realize that everybody's environment, when you look at how you would utilize it and the type of hardware that you would do, it can be unique. And like I mentioned before, maybe you're doing something a little different in plastics and you need a different looking HMI, something that might be more blow film mold, for example, that gets rolled onto rolls and then cut and put on pallets and etc. The good news is the HMIs can take on the persona of your type of manufacturing, and that's the key. You may have hoppers to where we need to do some that get blended, and we have weight controls for raw materials. You may have recipes to where there's an expected mix that ultimately would get changed when we go on to the extruder, for example, things like that. The good news is it's not one size fits all. This is where we look at your individual situation, the type of manufacturing you're doing, and then our team is very good at helping you dial that in so that you can really start to transform your factory floor into a smart factory. Other use cases, you may have places to where there are machines or manual processes that parts are getting created and things are getting moved. We can do those with all types of sensors and other ways to optimize. Thing from line break sensors to cameras to RFID. There's just all types of opportunities in which we can take what were traditionally manual processes that we had to write down production or maybe try to scan it, that we can look to optimize that and bring that into the framework of industrial IoT. So the opportunities are numerous. We know that every plant floor is going to have some uniqueness. You're going to have new machines. You're going to have some older machines. The good news is the smart factory application comes out of the box with all the connectors that you're going to need to talk to all the various machine platforms. We have thousands of connectors and the ability to read those machines up to 10,000 times a second. Not that anyone would want to do that, but some places high-speed data acquisition can be extremely important. So within this environment, regardless of kind of the machines you have, if they are older, then we will utilize a couple of different techniques. Sometimes machines will have a controller and we'll be able to talk to the PLC. In other cases, it may be a little older machine, and within that, we can use some of the more advanced capabilities called an edge device. That's a little small computer that gets sit within proximity of the machine, and then we can have like a temperature or an injection pressure, voltage. Any and all those can be done through the edge device, and this we would not have to hardwire really anything into the machine. So the good news is this application and its capability really gives our customers and prospects a whole new world of opportunity of how they would look to automate for today and into the future, and bring together kind of a manufacturing network that really enables them to address all those problems that I talked about up front. How we address the margin pressure, how we address everything from the demand spikes to the customer expectations, the worker and skill gaps, if you will, and give you the ability to really drive information to your shop floor that will help you today and into the future. So with that, we're kind of at a wrap. Got contact information there for folks.